All right, now we're going to look at the second free response problem from review day number 11. We get this very crazy looking graph. We're told this is just two line segments. Make this triangle here. We're told that A has an area of 3, B has an area of 5, and that this function is negative x squared plus 5x minus 4. Okay? And first thing then we're told g is the integral from negative 4 to x of this function up here. All right, so that means that g prime of x is equal to f of x. That's always a good thing. If you see something like that, that's always a good thing to write down on your paper right away. Sometimes you'll get a point just for that. So we're supposed to figure out what g of 0 and g of 4 is. So we'll start with g of 0. G of 0 is going to be the area from negative 4 to 0 of f by definition here. And so that's this triangle. That triangle has a base of 3, a height of 3. So 3 times 3 divided by 2 is 9 halves. And then we're going to add to that this area, which is negative 3. So if you left it, that's fine. This is negative 6 halves. So 9 halves plus negative 6 halves would give us 3 halves. They gave you a point for finding that. Okay. Now, as far as g of 4 goes, g of 4 is the area from negative 4 to 4. Now, that would be the 3 halves we just found, plus the area from 0 to 1, which is 5, plus the integral from 1 to 4 under this thing, which is negative x squared plus 5x minus 4. Okay. So this is going to become 13 halves, plus, if I integrate, I'll get negative x cubed over 3 plus 5x squared over 2 minus 4x, and we're evaluating that from 1 to 4. So now this part becomes a little, kind of a little cumbersome. You have to integrate, you have to put 4 in and calculate that all out, then minus and put 1 in, calculate it out. If you left it all stretched out, as long as you had put 4 in, minus 1 in, and have 13 halves, technically that all is correct. But if you do simplify it, it all comes out to 11 in some kind of magical way, right? So how did they give you a point? They gave you a point if you expressed the integral from 1 to 4 of this. They gave you a point for having the correct integral of it. So if you knew that you were supposed to integrate that, you got a point. And if you did it correctly, you got a point. And then if you had the final answer, so I'm assuming with this stuff included, that'd be a point. You don't have to have it say 11, but you do have to have all the pieces in place with it. All right? So kind of a crazy one there to start off. Then it says find the absolute minimum of g on the closed interval negative 4 to 4. So again, let's think about what's happening here. Initially, because the derivative of g is f, what's happening first is g is increasing up until this point. Then it decreases again. So if you kind of just did a little sketch of it, it's increasing until negative 1. Then it decreases until 0. Then it increases again and increases for the rest of the time. So where would my minimum be? Maybe at x equals 0 or at x equal negative 4. Okay? So we would probably want to argue here that the absolute minimum can occur at x equal negative 4 or x equals 0 because g prime, which is f, is positive for negative 4 to negative 1 and 0 to 4. So by expressing an idea, or you can say that it was increasing up to this point, decreasing, one or the way or the other, that gets the job done. Now they gave a point for just expressing g prime equal to f, and they gave a point for identifying negative 4 and 0 as your candidates there. Okay, so then how do we know which one's the absolute minimum? We just go ahead and find them. G of negative 4 is the area from negative 4 to negative 4, which is 0. And g of 0, we actually figured out in the first one, that was 3 halves. So the absolute minimum is 0. And that gave you another point. Okay. Now, find all the intervals where g is concave down. G is concave down when g prime, which is f, is decreasing. And so we go back to our graph, and we're decreasing from -2 to -1/2. I write that down, and then from 1/2 to 1. And then we have a third time at 2.5 to 4. So 5/2 to 4. So there's 3 intervals, -2 to -1/2, 1/2 to 1, 5/2 to 4. You got a point for saying this part and then a point for saying that part.